So here it also requires us to draw a model for the real conductor, include this resistance. So this model should look like the following. Intuitively, it should be, this is R, you measure, and then this is the L, which is 100 millihenry. Okay, let us move on to the next procedure. So because there are many disadvantages of that model, so in this procedure it also introduces another model called simulated inductor circuit. And there is this part is an introduction for this circuit. So now we move on to the procedure 2B. So the 2B, you have to build the circuit of figure this one. Using the simulated inductor you built in 2A. So note that the battery is also 9 volts. This is 9 volts for supply the OP amplifier. This also means that this is 9 volt, this is 9 volt. So you put this circuit to here. So this inductor is simulated. This one is simulated inductor. So set up to monitor inductor current, either directly with your multimeter or by observing the voltage across 1 ohms resistor. Use the measure value, resistance value of the 1 ohm resistor for the current calculation, which means that 2 ways to calculate IL. One is to measure IL directly. The other one is to measure the voltage across this 1 ohms resistor. But you have to utilize the measured resistance instead of 1 ohm. So for example, it could be 1.2 ohms resistor. Okay, and this part introduces the disadvantage of the simulated inductor. For example, this part has to be ground. So this is one disadvantage. Now, we have to do something for this circuit. The first one is you have to monitor the inductor current when the switch is in the down position until it is less than 7 milliampere, then move to the up position, to the position 1. So which means that in the position 2 you discharge such that the IL is less than 7 milliampere, and then you charge it. So now after the switch has been in the up position 1 long enough, measure and record the inductor current and voltage. Compute DC resistance of the inductor. So you have to measure and record inductor current and voltage, this one, IL and VL, and then measure the DC resistance. So for example, the resistance could be 99 ohms. And now move the switch to the down position, so we discharge, and record the IL every 15 seconds for 3 minutes, and then graph it, and then judge if it is linear, exponential, or quadratic, and then determine the time constant, which you have done in the previous procedure, and then determine the inductance of the simulated inductor from the time constant. Because now you know R and you know the time constant, then you can find L. So you calculate the inductance from the time constant, resistors, which is 1 ohms, and then the internal resistance, which you do previously, which is, for example, 105 ohms. So this is internal resistance. And then you can calculate the inductance.